Hi everyone, my name is Nidaa, and I've been a backend developer for about 8 years now. And so today I wanted to go a little bit into RAG, or Retrieval-Augmented Generation, and just kind of go step by step into what this means, how it works behind the scenes, and then also go through a personal project that I've been working on that I will get to a little bit later. So my first slide, I just wanted to talk about AI in general, right? So for me, this is what it's felt like, I think, the last year. The last several years, we've been hearing a lot about, AI is gonna, there's an AI revolution, and it's gonna take our jobs, and it can write code, it can pass the bar exam, it can write a novel, and all of these other things. And at times it just feels very overwhelming because, some of that hype is real, and some of it may be a little bit more exaggerated. But for me, one part that really stands out in this whole AI wave is RAG. And I think it's actually a very powerful and the most practical pattern that I can see, at least in my opinion, that we can use and kind of inject at different parts of the life cycle, whether it's a software development life cycle, whether it's client ticket resolution. So I'll get into that a little bit more, but I think for me to really kind of explain why I believe RAG is as powerful as it is, it might, make sense to step back a little bit to see how we got here in the first place. So let's rewind, right? So for years, AI has been all around us. We may not necessarily have thought of it as AI, but our next recommendations, for example, that's using some type of filtering logic, right? So fraud detection, for example, or spam filtering in our Gmail, that was also using anomaly detection, for example, and Google Translate. So, way before LLMs like ChatGPT, hit the scene, we had statistical machine learning that Google Translate has been using for years. And what it would do is it would just translate the words for us, but not necessarily the meaning or the larger context behind it, right? So while the traditional machine learning models have been very powerful, they've also been quite narrow and kind of like task-oriented. And usually we would need to provide some kind of structured data, right? So that was kind of like the limitations of the older ML models. And then we came to today, we have the explosion of LLMs like ChatGPT, and initially it sounded great, right? So let's say in the first example, many of us are Auslanders living in Berlin. Maybe we know some German, maybe we don't. And we get a letter from our landlord saying that our lease has been terminated. Okay, so what would I do? I would just go to Google Translate and try to understand, okay, what is going on? What does it say? And yeah, now I know what the English translation of those words is, but what does that actually mean? Is this breaking any laws? Is there anything that I might be missing? So today, I could go to ChatGPT and tell it, okay, well, what does this do, right? Like, what do I need to know? And ChatGPT actually seems to understand the meaning behind it, right? And at first glance, I think a lot of us just thought that, wow, it's magical, it's a solution to everything, until we start to find out that it's not as perfect as it might appear. Because ChatGPT could tell you that, your landlord is breaking the Section 7 of the German Housing Act, and it turns out that that doesn't exist, right? So that sets the stage for RAG. But before that, just to go a little bit more into the limitations for LLMs. So why does that happen, right? Why does ChatGPT and other LLMs hallucinate? That's because we have a knowledge cutoff, right? So some of these models have maybe their training data stopped last year or a couple years ago, so they are not aware of recent events, right? They are not getting any real-time updates of current events, newer developments, things like that, and stateless. So usually, traditionally, it's been every new prompt starts fresh, right? So now we have kind of like web browsing capabilities or maybe shared memory across chats. But in general, you have to manually upload a file. So for example, your lease agreement or anything at the enterprise level, business rules are constantly changing. So if we want to use ChatGPT, we always need to kind of update the latest documentation, manually kind of put that static data, so that is tedious, right? So any information that you want it to have, you kind of need to manually feed it or take the risk of the hallucinations, because that is by design. So that brings us finally to RAG. So what RAG actually does is just kind of insert a data layer in between the user's query until it goes to the LLM. And I'll go into that in a little bit more detail, but the end result is that we can have more accuracy and reliability in the responses that we're getting, because we can trust that it's using real-time data. If we have a data pipeline where we're consistently kind of updating and making sure that the information there is accurate, we kind of can avoid the hallucinating problem. So I think a lot of people might think of RAG as, okay, I just upload a bunch of databases, or sorry, a bunch of files into a vector database and then I'm done. But I think the true potential of RAG lies in this continuous update. So having some kind of process that is, for example, application logs, that every day we have our application logs being saved to a vector database. That is where the true potential of RAG comes alive. So what does that entail? Before we can even query the database, we need to first store it. And so there's normally every RAG process is a simplified version, but every process would start with loading or collecting the data, maybe cleaning it in some way. And then before we send it to a model, so there's a lot of models available, OpenAI, there's Gemini, a lot of the major providers, but we would need to chunk it or split it into what makes sense. So here there's some granularity involved. We might have, if you have too little data, then that's also not good. You have to kind of balance how much, because this will influence the accuracy of the results as well. There's also, we can overlap to make sure that, because the way the embeddings work is that we will get a number, kind of a vector of 1536 digits, or there's different ones, but the more detail we can send, the better our results are going to be. And I will show that in just a little bit. So this is the normal process. So we collect the data, we split it, and then we embed it. And after that, we get back this vector. So here's where it can differ, right? So we have some providers where this is all completely managed. There's OpenAI, Gemini, and a few others where you don't need to worry about your own vector database, and it will just handle all of the indexing and querying for you. And that is fine in terms of basic data structures or static data that doesn't get updated very often. But if you do want to control the indexing, the filtering, or what kind of data you're actually saving to the database, then you might want to have your own vector database that you manage yourself. So then that brings us to the query. So what would happen in the typical RAG flow is the user, let's say they ask a question with a typical chatbot. There is, and this is not here, there's a decision layer to this, because we need to identify, do we want to use the RAG, or do we want to go directly to the LLM? And now there's different ways we can do this, but generally it might involve using some kind of keyword or classification. So for example, in the law example, if my RAG or my bot sees certain keywords like tenancy law or Berlin or something like that, then it knows, okay, I might need to search this. But if it's something completely unrelated, like matcha cake, then it just skips all of this, goes directly to the LLM, and it's just your normal kind of GPT response. So yeah, and I'll get a little bit more in detail about that down the line. But that brings me to my personal project. So, fun fact, I actually very nearly became a lawyer before going into programming. So I'm very passionate about the law and also about AI and programming and things like that. So this was my way to combine both of these passions. And I've been in Germany for a while. I speak some German, but not good enough that I can understand legalese, right? So I found the BGB, I always forget how to say the German word, but in English it's the German Civil Code. And actually they have an official English translation on their website. So what I did, and I'll go into this into more detail, but I went and found that, and it turns out that it's not, well, compared to other countries, there's also case law and things like that, but it covers a majority of the rights that someone can have in Germany, and you know what that entails, and I'll have a demo at the end where I can show you. But all of the theories that I just explained, I'll walk you through how I put that into practice. Exactly. So step one, like I mentioned, data collection. So this is the official website of the German Federal Ministry. So as you can see, you can change the language between German and English. And so this was the official English translation. And the source looked something like that. So that was not very easy to parse. There was a lot of inline CSS styling. So in order for me to even chunk it, there was quite a bit of parsing that I needed to do and removing a few things. But essentially, the interesting parts here are that every single section, like this, so this is one section, they have an ID in the anchor tag. And also, the subsection has a different ID. So this is where I also needed to kind of fine-tune it a little bit, because I needed a way to make sure that in my vector database, all of these subsections are still tied to the main section, so that when my bot is responding, it understands that these two things are related, right? Like this paragraph is related to this paragraph, which is why it wouldn't make sense for me to use a managed service, because I need to be able to decide which information I'm saving and how I'm going to query it and filter it and so on and so forth. So this is what my embedding looked like, right? So after I cleaned the data, I chunked it, I sent it to, I use OpenAI, but I think all of the other models have similar services. This is what I ended up storing. So I don't have a vector database yet, because this is still very early stage, but I just have a JSON file. So the embedding normally would have, from OpenAI, you would get 1536 numbers. So I didn't want to put all of that, but you get the idea. And here you can see, so these are two different, this is a subsection. They have the same section ID, but different chunk ID. And this will come in handy later on when I do the demo, and I'll show exactly how it comes into play. But I wanted to just have this here to show that this is just one example. This was my specific use case, but there's so many options available out here, open source or paid services. There's a lot. So I would encourage you, if you're interested in this, to just try out. Maybe I don't think there's any one-size-fits-all solution here. It's a matter of your own needs and how you want to scale it down the line. These are just a few examples. So the step 4 for me, so we do have the English language page already, but I wanted to have my own static HTML page, which has exactly the same content as the official one, but I wanted the chatbot to link here in a kind of like in a smooth way. And so this is where the IDs come into play. So it's actually the same content that I used to chunk. So this is on my static HTML page and preserving kind of like that same structure and relationship in between the different nodes or the different sections. And that brings us to querying. So I mentioned before, we have the user input. We actually need to embed it the same way that we embedded the original content. And then fetching top K chunks. K is just a number that we set. From what I read online, 3 is a typical number, so I just set my K to 3. And then we enrich this, and then we send the prompt to the model. So this is actually what it looks like. So the user enters a query. So again, there's going to be a decision step. Do we need to use RAG or do we not use it? So the same exact model that I use to embed the original data is the same one that I'll use here to embed the query. Then we do a vector search, which basically now will return me top 3 chunks that it finds in what is called a semantic search. And this involves cosine similarity, so there's different ways to do it. This cosine was actually the simpler way that I found online, and that was like for my use case, it was perfectly fine. And what it really means is that we get the top 3 chunks, we have the user query. How do we know if this is relevant or not? Because it's possible that the answer we got back isn't relevant, right? So this is where cosine similarity comes into play, where the angle, the larger the angle, as you can see, that means the less similar they are. And now again, this is a number that we get to set in the background. And I just use kind of like defaults that I found online. But basically, this is how you will choose whether these are relevant to the search or not. And then after doing all this is when we then assemble the prompt. So again, we want to kind of tell the model what to do, whether to use it or not use it, and how to use that information. And there's a lot of fine-tuning involved here as well, because you don't want the model to hallucinate, but at the same time you don't want it to be too restrictive. So I had to kind of like engineer the prompt a little bit there. But now I'm ready to show the demo for this. So this is, I have it hosted here right now. Why is it not showing? All right, so this is the demo of the chatbot that I created. This is just the first version. It's still early stage. So like I mentioned right now, I've only trained it on the static data, which is the German civil code. So here's an example if I were to just ask this question. So as you can see, I actually told it in the prompt that it should always link to the specific sections, because it's important, especially when it comes to these matters of law, that we know it's not hallucinating and not giving us wrong information. So then when we click on this, this links to my static website. It's just simple HTML, but I also link the external reference here, which does go to the official page, which is, this is the English version. It goes to the exact section that we just looked at, and then there's also the German translation available on this same page if someone wanted to make sure that that what is the original language saying, what is the English translation saying, because I think in this matter it's important to have kind of like this reliable and security, not knowing what is the real data source. So this is why I took every precaution to make sure that we always link back to the real source. So yeah, like I mentioned, right now this is static. But down the line, I do want to implement kind of a web crawling functionality to this, because aside from the German civil code, like I mentioned, we also have previous case laws, we have legal journals, we have new decisions being made all the time. And so like I mentioned, RAG is only powerful, or it's much more powerful when the data is being kept up to date. So yeah, if anybody has any ideas and wants to collaborate, I would love to hear from you. And yeah, I will actually link page to this. So if you go here, you can see the demo, you can try it for yourself. There's also my GitHub link there if you want to look at the source code or contribute, feel free. And I would love to hear from you and connect with you on LinkedIn. If you have any ideas or want to collaborate on anything, I just want to say thank you so much for listening to me. I hope you learned something new, that you found it also interesting. And yeah, I'm ready for any questions.